All right, we'll go ahead and get ready to get started here. Last session of the day. Thanks for sticking around. I want to introduce Lindsay Nystrom. So Lindsay is another one of the student award winners that have been presenting in this room here throughout the day. Lindsay is from UNC Asheville. She's going to talk to you guys about using GIS to understand coastal hazards in the U.S. So Lindsay works with me and several of my coworkers, and I like to brag on her a little bit. She's only a freshman this year at UNC Asheville, but she's already doing some amazing GIS work and actually had the opportunity in high school to take 12 credit hours of GIS classes through a local university. So pretty rare, I would say, this day and age. So with that, I'll turn it over to Lindsay.
All right. Hello. As he said, I am Lindsay. So, again, as he said, I'm a freshman at UNCA, GIS intern with NEMAC, and I grew up in Loudoun County, which is like the tippy top of Virginia. And basically, they had a program there through James Madison University where I could take credits for GIS that count as college credits and high school credits. So yeah, that was a really wonderful program, and I did a lot of projects, but here are my favorite. So I looked at the change of development in my county, and I looked at how certain aspects of development are scaled and proportionate as population increases, and that was in Charlotte. And then my big final project was looking at how different chemicals spread from fracking and how deeply they affect groundwater. So now I'm working with NEMAC, which is an applied research center through UNCA, and basically their goal is to communicate hard data into something usable and inform decisions. So we're not really the ones making the decisions as to where things should go and what this means, but we're giving it to our clients in a usable manner. We get our data we work with NOAA and the U.S. Forest Service and other local agencies, state agencies, nonprofits, engineering firms. So we have a wide array of partnerships. And so, yeah, that's basically what NEMAC does. And specifically, what I've been working on is the coastal resilience assessment. Basically, this is with the National Fish and Wildlife Foundation, NIFWF. And the idea is that we can create resilience hubs. That's the final end product. And those are areas that would be most benefited by a project to encourage or to improve resilience to flood damage. So basically, NIFWF has these grant awards, and our job is basically to say what areas would be most benefited by a potential project. And so that's composed of a few different parts, but a main part of it, which is what I specifically mostly work on, is the exposure index. So there are two parts to that, which are assets and threats. You can see the list of what goes into each one, but basically an asset is a community asset, I guess, that just helps the community in different ways, but specifically that would be affected by flood damage. And then with threats, it's things that are potentially harmful with flood damage. And this is kind of an example of how we visualize that. So the red are threats, and the darker areas mean more threats, and the blue are assets. Darker blue means more assets, and they're combined to create this overall exposure index. And so we've done this, we separate it by region. So these are all the regions we've done so far. And they're the Huck 8 watersheds, which is why they have kind of weird boundaries. But we've done that so far for the whole continental United States, which this is the exposure index for the entire country, or continental country. So my job specifically is to help create the inputs for these indices. So I'm making the layers that we saw listed earlier under assets and threats. I did a little bit of work to create hubs in the Pacific Northwest. And then I've also started to work on Puerto Rico. I did a little work with the North Atlantic, and we're now moving on to Hawaii. So I'm just going to kind of go through some of the layers and maps that I've made since I've started working with NEMAC. So critical facilities, this is in the North Atlantic. Basically, these are places that if they were damaged by flooding would impede a community's ability to respond from that event. So the dark purple areas is a little hard to see, but basically each dark area would be a place deemed a critical facility. And this can be anything from medical facilities to emergency response facilities to education facilities. So there is like a wide array, but they're all like fall under the same category. So with storm surge, basically the way that we address this is separating it by the category of storm. So an area that would flood from just a category 1 storm would be considered hot or like more vulnerable than an area that would flood after a category 5 storm. So those are like kind of inverted numbers, which can be confusing, but it basically is showing that with less flooding, if an area floods with a lower category storm, that would be more at risk. So this was the hubs analysis that I did, which was definitely the most frustrating of all of them and the most difficult, just because I had never done anything like it before. I had to use QGIS for the first time, which I had never used. And it was also just like timing with schoolwork. So this whole process was very interesting, but also I learned a lot from it. And basically this is just showing where in the Pacific Northwest would most benefit and is most vulnerable to flood damage. So yeah, that's that map. So now we're moving on to Puerto Rico, where drainage and erosion, they have a similar methodology as far as creating this map goes. But the biggest thing for me personally that I had to learn to handle was transforming the data from non-spatial to spatial, which was, again, a new process for me that like in high school, I had never done before. So this one, again, took a little bit longer to actually create, but it basically just ranks what areas have low and high drainability and what areas have low and high erodibility. And basically, we got that data from the USDA Web Soil Survey and just changed those spreadsheets into like spatial data that's usable and visualized. Moving on to Hawaii, this is what I've most recently been working on. I've been doing the threat index, and the other GIS intern is mostly working with the asset index. So when I started working on this was right when the government shut down. So there was a little bit of trouble with data, but using like different back channels, we were able to get through and like actually get the work done. But once we had the data, it was really nice because it's such a small landmass that we could process things really quickly. And so this work like moved really quickly. So we have like quite a few layers for this that we were able to complete. So sea level rise, this is pretty straightforward. Basically, the areas on the coast obviously have more higher sea level rise. And that's a zoomed in view of the island Oahu. And so this was one of the inputs I made. Also slope. So the importance of slope is just that areas will flood easier if they have a lower slope. And so for obvious reasons that would be unfavorable in a severe storm event. So this is kind of showing what areas would be more vulnerable because solely of their slope. Then moving on to erosion. So as I mentioned before, originally erosion and drainage were a frustrating and difficult process, but by this point I had like gotten the hang of it. And so again, and especially because of the processing time, I mean, we were like flying through these, which was really nice. But this is the same thing, view of Oahu, basically just showing what areas would have higher erodibility and so would be more damaged by flooding. And then storm surge, so we talked about this earlier, but basically if it floods in a Category 1 storm, it means it's more vulnerable. And so this is kind of showing, this has a pretty, I think this is an interesting map just because it like either has intense flooding at Category 5 or intense flooding at Category 1. And there are other areas that are smaller or more varied, but I just think that's an interesting pattern that we see. And then lastly, I just want to talk about just like how grateful I am to have this opportunity to work at NEMAC, and also how important I think it is to incorporate GIS into public education and into like higher levels of education. I've definitely learned a lot, and every time I go to work, I learn more. And I think it's just important to share this technology with a younger population as soon as possible, so that we can start doing this kind of work. And I've also learned a lot, I think, about just how versatile GIS can be, and just how many different applications it has, and specifically like with the work we've done, how many different parts go into climate science and stuff like that. So yeah, I'm looking forward to more work with NEMAC, and I think that's all I have. Do we have questions? Yes.
You said you had some software problems. Was that working with large rasters and GIS?
Yeah, it was mostly, so like we have our computers at NEMAC, right? And then we also have our machines from the school. And because just like of the timing of that period, I had to work a lot outside of the office. And so the computers weren't as like efficient. And so like with large data sets in QGIS, they did not mesh well. But
it might be better to use grass for large data sets when you are doing things like master algebra. It's more efficient to utilize than QGIS is. So if the grass is installed with QGIS when you do it on Windows, start grass separately, you should be able to run that large grass more efficiently. Just for future reference.
yeah, okay. I appreciate that. Any other questions? All right. Oh, yes?
Is there anything you talk about using the 12-digit hubs for these analysis in place of the 8-digit, especially in places like Hawaii and Puerto Rico that are much smaller?
Good question. This might be a question for Greg.
Yeah, we have. And so there's one other kind of side of this that Lindsay didn't really get into, but we're also doing like efficient wildlife assessment as well. And so for that analysis, we are working down to the 12-digit level. Some data from NatureServe that they've collected that indicates very weighted richness of species across 12-digit hubs. So definitely. The reason that 8-digit watersheds were chosen, EPA designates the up to 8 watersheds that drain directly to the coast as coastal watersheds, so that kind of set the boundary.
Yeah, that was something I forgot to mention, was that the whole point of this is that we're using a dual approach where environmental factors are considered through the Fish and Wildlife Index, but also community factors are included based on, well, exposure, but that also includes environmental factors. So just using both sides of it. Okay, cool.